Hello, good morning, everyone. Thank you for having me here. So usually in Indonesia, before we start, we say a greeting, Assalamualaikum, Shalom, Om Swastiastu, Namo Buddhaya. So it's like signifies the diverse culture that we have, because we are indeed a very big country, and we actually are the biggest archipelago state, and this has posed a challenge electrification, providing electrification in rural areas. So we have 17,000 of island, and in order to provide the electrification, we have to rely on 900 isolated grid. So, but it only can achieve around 67% of electrification ratio back in 2010. So the government really want to increase until 100 until this year, and good progress has been achieved. We already at the 99% of electrification ratio, although there is a controversy about what is the definition of electrification rate in Indonesia. But anyway, I think I'm going to share right now about the experience that the government Indonesia has done for increasing the electrification ratio. So apart from a lot of islands challenges, we also have the fourth biggest population in the world, 267 million people, which also correspond to the energy demand, a very high energy demand. We can, like this year, we have 114 million ton of oil equivalent for the energy demand. The 40% is for the transportation, and around 36% for the industrial. So the government has mapped out the projection of the energy demand up until 2050. And there we can see here that the business as usual scenario will land us in 550 million ton of oil equivalent annually by 2050, which is such a huge energy demand. That's why the government also have this low carbon scenario that will reduce by around 120 million ton of oil equivalent per year. And fortunately, all these 75 years, we already have been blessed with abundant energy source from coal, oil, and gas, but it will not last forever. So the coal will only last until another 80 years, and also for gas is another 30 years, and oil is even shorter, another 10 years. That's why the government also have this scenario for energy transition, so that all the Indonesia can have a sufficient energy supply in the coming years or decades. So as we can see here, the list that the emphasis is put on the biodiesel, and also there's some of the emphasis on household solar rooftop, and also on biomass and bioethanol. We are also starting to plan for electric vehicle. So fortunately, we have abundant amount of renewable energy resources. So if we utilize all the renewable energy, we will have around like 442 gigawatt. But unfortunately, we only have 2.2% installed by this year. And why is that? Is because the very high annual investment costs. So this is the calculation is done by World Bank back in 2017, that Indonesia need around 9.4 billion US dollar for the annual investment of renewable energy. So moving forward, this is only some of the strategy that Indonesia have done or will be doing in the next couple of years in order to increase the rural electrification ratio. So we can I will only just discuss a little bit of it. Back in 1990, we have to rely heavily on micro-hydropower power plants, because at the time we all know that the PV and the windmill is still very expensive. And during that time, we already implemented like around 1,300 projects, but then there's an ESMAP report that evaluates the sustainability of those micro-hydro power plant project. And that we can see here that in 2018, one of the challenges of sustainability is when the main grid arrive at the off-grid. So it can be a challenge because it's competing the off-grid, the microgrid, but it also can be, collaborate together, like in 9 microgrid, the off-grid micro hydro connected with the main grid. And in another 40 to 50 villages, the microgrid are still isolated, and the community is still using the electricity from the microgrid. So in this case, it's really sustain the microgrid, because it's lower. It's over lower tariff for the community. So that's one part of the sustainability. And the other lesson that we learn is from the project in 2007 is an energy independent village. They have these two types of project, the biofuel based power plant and also the non-biofuel. And we learn very instantly through this project that the biofuel based power plant is not very effective conducted in rural areas. So it's very challenging. And I will move forward to the one of the experience that for me is the most monumental is the 2010 project, the Sumba Iconic Island. The project lasts for around 10 years. So this year is actually the final year of the project. So in this project, they choose the HIVOS choose a Sumba Island that has the lowest rate of electrification. At that year is only 25, and within 10 years they're aiming to achieve 100% of electrification rate, but unfortunately they can only achieve 50% by this year. So I'm going to share a little bit about the lessons share from the Sumba Iconic Island. We can see here that in Sumba Iconic Island they try almost all types of renewable energy. So, but most of them are installed isolatedly, so it's not connected in a microgrid. Yeah, so we are not in that stage yet. But we can see here that the robustness of solar PV and also micro hydro to be installed in the most rural area and among the indigenous people. So these two type of technology can be easily sustained by the local people because it's quite simple for them. And but we can also learn that the investment cost is still very high. It's around $7 million per year. So that's why when I hear about what Dr. Dehan has shared before about Python software plan that could really lower the investment cost, I think it will be very suitable to be applied in Indonesia or in another country, because in Indonesia we still have another 433 village with no electricity. So I think, yeah, I'm very excited with what the Crescent HIROS team is doing right now to develop the Crescent, to develop the software. And so from those experience from Sumba Iconic Island, the government really put to level up, increase their game by 2016. So in 2016, they launched this regulation that they will emphasize the renewable energy for any rural electrification, and that they will achieve 100% of electrification by 2020. But they can only do it with step-by-step approach. So for the scattered villages, they only provide the solar lamp and a solar lantern, and the microgrid only is planned and developed in the centralized village where there will be no distribution line in the next 2 to 3 years. So this is a very step-by-step approach, and they don't put emphasis on another biomass plant because of the experience previously. But it raised a question of whether a hybrid mini grid will be ever implemented in Indonesia, and the answer is yes. So the government is planning for another 13 location for mini hybrid for the hybrid mini grid. So the location is chosen carefully, is usually for the collection of small islands that have strong economic activities, like Professor Nico has shared before about the importance of economic activities for the sustainability of any microgrid. So in this island, the chosen, the government has to see that there have been a robust tourism activity or either fishery activity. So in case of a biomass power plant, and whether it will be installed in any rural area or not, there are still some pilot cases, even though the previous one has not been successful. So this is the new approach. This is in Mentawai Island, and there is the other one is in East Nusa Tenggara, also with using the bamboo plants as feedstock. And here is launched in 2018, so we are still cannot evaluate like how about the sustainability of this plant. But hopefully it runs smoothly so that it can be implemented more widely. So I conclude my presentation here, and I turn back to Petros. Thank you everyone for the good. Okay.
Thank you, Elisabeth, for the very nice presentation and for being on time. Don't know if there are any questions. Again, the chat is open if you want to ask any questions. I will start by asking a question. RDI and Indonesia, you have lots of experience in microgrid projects over the years. We, from the academic side, we look at a lot of technical challenges. We look at a lot of optimization problems, control problems. You are from a different perspective. You can have a more wider view. So what do you believe are the main challenges now for getting microgrids out there? Is it technical problems? Is it policy problems? Is it economics, finance, how to finance them, business model? What are the main challenge? Is it the technical side that we academics believe it is, or is it something else in reality?
Yes, I think all aspect is contributing to the challenges, Petros. That's why, as I mentioned in my presentation, the government approach is quite simple. To the most remote area, they provide the solar lantern. But I think the social and the cultural also is a big challenges, like Prof. Nico has mentioned before about the business model. And I think it will be discussed further in the next Crescent Hires seminar in 17 September, if I'm not wrong.
Okay, maybe I'm moving forward too fast then. Thank you. There is one question from Chun Singh. So he thanks you for your excellent presentation, and he's asking, can you share regarding the energy storage development and adoption to deal with large penetration of renewables? Meaning, what is your view
Yes.
on energy storage and
Yes, yeah. Thank you for the question. I think energy storage is the main, one of the main hindrance of the investment costs for any microgrid planning. So I think right now in Indonesia, we haven't progressing much in the energy storage. So most of the energy storage existing right now is quite very simple. Actually, is based on the accumulator. But I think it will also discuss in another in another seminar. I think the bioenergy base. Part of the Crescent Hires team is doing on that as Professor Andrew or Andy is trying to make this biofuel as a way of conserve the energy instead of using it in a very expensive or maybe energy storage, something like that.
Okay, so that's again another reason to attend the next two
Yes.
workshops. So there are two more questions, I think. One is from John Lovett. So he's saying that Shahab mentioned that there is a problem with data
Yes.
availability in many countries. How is that in Indonesia? Do you have access to enough data to do this proper planning?
Yes. I think that's also one of the biggest challenge because also definitely actually um, to get very continuous data, we need a data logger, but I'm not sure that the government, local government has that kind of capacity and then has the kind of interest to store that kind of data. But I think the local electrical company, the PLN, they have these offices in the regional, they have that kind of data. But then again, because they are really focusing on the main grid instead of the off-grid, so they are having this data only not in the location where there should be a mini grid. So they have it, but I don't think it will represent exactly of what is going on in the off-grid area.
Okay. I think I will take one more question and then we have to move to the next, and I will forward the rest of your questions to Elisabeth. So
Yes.
next question is from Johnson, says, how does renewable energy play a role in electrification in Indonesia if the rate is almost 100%?
I think that's going back to the definition of electrification rate. So yes, but yeah, I don't. Okay. Uh, Actually, the definition of electrification rate right now is the availability of any electricity device. So it will actually. Dr. Cheng Wen will talk about that, I think, more in the next Crescent Hire seminar about the quality and the quality of an electrification rate. So okay, on the paper we have like almost 100%, but in the regarding the quality, I'm not sure that it corresponds. Maybe I will stop there, Petros.
Okay. Thank you very much. I have forwarded you some questions that were remaining. Pierre was suggesting some platform to store open data And there were a couple of more questions. So thank you very much for the very interesting talk.